Biodegradable materials play an important role in modern waste management and environmental sustainability because they provide an appealing alternative to traditional petroleum-based plastics. These polymers, which may be broken down into simpler molecules like water, carbon dioxide, and biomass by the action of microbes, greatly minimize the environmental effect associated with usual plastics. Firstly, biodegradable materials reduce the strain on landfills by breaking down naturally, which reduces the buildup of plastic garbage that endures for generations. This reduces the possibility of environmental pollution and the related health hazards in addition to saving important landfill space. Second, by reducing the amount of toxic microplastics released into the environment, the natural breakdown process protects ecosystems and minimizes the negative impacts on wildlife. Additionally, a lot of biodegradable materials come from renewable resources like microbes or plants like cellulose and cornstarch, which lowers our dependence on finite fossil fuels and encourages a more sustainable and environmentally friendly economy. The trend toward renewable resources cuts the environmental effect of fossil fuel extraction and processing while also reducing carbon emissions. Lastly, sustainable waste management techniques become achievable by biodegradable materials. It can be possible to successfully compost a variety of biodegradable materials, turning organic waste into beneficial soil additives. This promotes sustainable farming methods and healthy ecosystems by improving the soil and lowering the amount of garbage that ends up in landfills. To sum up, using biodegradable materials in our daily lives is a big step towards the aim of a more sustainable future. Biodegradable materials help create a healthier planet and a more responsible approach to resource management by cutting waste collection, lowering environmental contamination, and encouraging the use of renewable resources. Real-world applications of biodegradable polymers, PLA and PHA. Packaging industry. PLA, polylactic acid, and PHA, polyhydroxyalkanoates, are commonly used in packaging materials such as biodegradable films, containers, and bags. PLA is widely used for food packaging, especially for items like cups, plates, and cutlery. PHA is also used in more specialized applications such as biodegradable shrink wraps and protective packaging. Agriculture. PLA and PHA are employed in agricultural products like mulch films, which break down after use, reducing the environmental impact. They are used for soil improvement, as they decompose into non-toxic substances that do not harm crops. These polymers are also utilized in controlled-release fertilizers and seed coatings to enhance agricultural productivity and reduce chemical runoff. Third is medical devices. PLA and PHA are incorporated into medical devices such as sutures, drug delivery systems, and implants. Their biodegradable nature allows them to safely break down in the body over time without needing removal. PHA is used in tissue engineering and wound dressings, providing biocompatibility and reducing the need for long-term medical interventions. Next is contributions to reducing plastic waste. So first, environmental impact. PLA and PHA polymers break down more rapidly than traditional petroleum-based plastics, leading to less long-term waste accumulation in the environment. This degradation reduces plastic pollution, particularly in marine ecosystems. Secondly, sustainable alternatives. PLA and PHA are derived from renewable resources, like corn and sugarcane for PLA and bacteria for PHA. This makes them more sustainable and reduces dependence on fossil fuels, contributing to a circular economy where waste is minimized. Last but not least, composting. PLA and PHA are compostable under industrial conditions, providing a more eco-friendly disposal option compared to conventional plastics, which can persist in landfills for hundreds of years. Welcome, friend. This is Case Study 1. Food Packaging Industry from Nestlé Malaysia. Nestlé Malaysia has incorporated biodegradable polymers into its packaging to align with global sustainability goals. For instance, they are experimenting with PLA-based film packaging for products like Milo and Maggi. The company is part of the Malaysian Plastic Pact, which supports efforts to eliminate plastic waste and promote a circular economy. The use of biodegradable polymers in these industries significantly reduces single-use plastic waste. Additionally, this shift aligns with Malaysia's national waste management policy, which emphasizes sustainable practices to manage plastic pollution effectively, Adopting compostable plastics enhances a company's brand reputation by positioning it as a leader in sustainability. This not only strengthens customer loyalty, but also attracts eco-conscious consumers, creating new market opportunities.
Now for case study 2. Retail industry, Tesco Malaysia. Tesco Malaysia, now part of Lotus's Malaysia, has been actively involved in sustainability initiatives, including reducing plastic waste. One of their key efforts includes the adoption of biodegradable and compostable plastics for their packaging and shopping bags.
Biodegradable shopping bags. Tesco introduced shopping bags made from biodegradable polymers such as PLA and PHA as an alternative to conventional plastic bags. These bags are designed to decompose naturally under appropriate conditions, reducing the environmental impact of single-use plastics.
These actions have many impacts to environmental and economic, and this is one of them. 1. Environmental. By adopting compostable plastics, Tesco Malaysia contributed to a significant reduction in plastic waste generated by their operations. This initiative aligns with the Malaysia Plastics Sustainability Roadmap 2030, aimed at promoting sustainable practices in waste management. 2. Economic. These efforts enhanced Tesco's brand reputation as a socially responsible retailer, attracting environmentally conscious customers and strengthening customer loyalty.
Second is future-upgrading biodegradable items. Plastics infused with bacteria or enzymes biodegradable conditions PLA then replaces traditional plastics then breaks down with organic self-degrading compost quality. Plastic using biodegradable or
Next, attention, circular bioplastics, recycling biodegradable polymers into raw materials to enable a circular economy and minimize waste too is self-degrading plastics. Plastics that decompose on a set timeline or under specific conditions to reduce long-term environmental impacts. Next, potential, circular bioplastics, recycling.
Environmental benefits and challenges. Advantages of biodegradable polymers in the environment. 1. Reduced plastic pollution. The biodegradable polymers degrade into natural products such as water, carbon dioxide, biomass, and other material, which makes the garbage heap free from the persistent plastics. 2. Decreased carbon footprint. Most biodegradable polymers are synthesized from renewable resources and therefore enable manufacturers to overcome the dependence on fossil fuels. 3. Improved waste management. A compostable biodegradable polymer can be composted under specific conditions and thus reduce the waste going to the landfill. 4. Less harm to wildlife. These materials do not pollute the marine and the terrestrial life as they break down more quickly than the conventional plastics. Environmental benefits and challenges. Issues related to biodegradable polymers. 1. Degradation process. Most of the biodegradable polymers need specific conditions, i.e. industrial composting environment characterized by set temperature and humidity. In natural setting, degradation may be arrested or could take a very long time. 2. Cost. The synthesis of biodegradable polymers is relatively costlier than generic plastics owing to the cost of feedstock, fabrication, and substantially limited scale of operation. 3. Industrial scale production. Owing to inadequate structures, lack of technical know-how, and inadequate supply of raw materials, increasing production to feed the international market is not easy. 4. Waste management. Due to their similarity to conventional plastics, biodegradable plastics have implications to recycling stream when not sorted appropriately. Moreover, if disposed of inappropriately in landfill, for instance, may not decompose as expected due to lack of air or other conditions needed. 5. Environmental trade-offs. Biodegradable polymers help to solve the problem of the environmental degeneration of plastics. However, these polymers also have negative effects on the environment manifested in the substantial water and land consumption for cultivating the material's production base.
These materials break down naturally, facing challenges such as the need for specific degradation conditions and high production costs, contributing to circular recycling applications. Their applications span various industries, from packaging to biodegradable medical devices, providing sustainable solutions to environmental and economic challenges.
However, there